start. After activity number 2.2, this experiment showed that just a few crystals of potassium permanganate can color a large volume of water about 100 ml. So we conclude that there must be millions of teeny particles in just one crystal of potassium permanganate, which keep on dividing themselves into smaller and smaller particles. The same activity can be done using 2 ml of Dettol in instant of potassium permanganate. The smell can be detected even on the repeated dilution. The particles of matters are very small. They are small beyond our imagination. So it means particle very small. Not can see in your naked eyes. Characteristics of particles of matter. Particles of matter have space between them. So let's start and we recall in activity 1.1 and 1.2 we saw that particles of sugar, salt, Dettol or potassium permanganate got evenly distributed in water. Similarly, when we make tea, coffee or lemon, nimbu pani, particles of one type of matter into the space between particle of the other. This shows that there is enough space between particles of matter and particles of matter are continuously moving. It means one by one. So let's start a activity 1.3. Put an until uh, incense stick in a corner of your glass. How close do you have to near it is so to get its smell? Now light the incense stick. What happens? Do you get the smell sitting at a distance? Record your observation. Take two glasses breakers filled with water. Put a drop of blue or red ink slowly and carefully along the sides of the first beaker and honey in the same way in the second beaker. Leave them undistributed in your house or in a corner of class. Record your observation. What do you observe immediately after adding the ink drop? What do you observe immediately after adding a drop of honey? How many hours of how many hours or days does it take for the color of ink to spread evenly throughout the water? Activity 1.5. Drop a crystal of copper, sulfate, or potassium permanganate into a glass of hot water and another containing cold water. Do not stir the solution. Allow the crystal to settle at the bottom. What do you observe? Just above the solid crystal in the glass, what happens as time passes? What does the suggest about the particle of solid and liquid? Does the rate of mixing change with the temperature? Why and how? Because of in temperature, your it means your gap very loose and then a particle behave as a liquid and in solid phase particle no move around it. So these different types of properties, solids, liquids and gas. From the above their activities, we can conclude the following. Particles of matter are continuously moving. That is, they process what we call the kinetic energy. As the temperature rises, particles move faster. So we can say that with increase in the temperature, the kinetic energy of the particles also increases. In the above their activities, we observe the particle of matter intermix on their own with each other. They do so by getting into the space between the particles. This intermixing of particles of different types of matter on their own is called diffusion. It means this is the definition of diffusion. It means in air, in water, uh, in a high pressure to low pressure move that the, this is called diffusion. We also observe that on heating diffusion become faster. Why does this happen? Because of uh, give a uh, external energy, so they give faster, move faster. Particles of matter attract each other. Play this game in the field. Make four group and four human chain as suggested. The uh, the first group should hold each other from the back and lock arms like Idu Miss Me Dancer, show this picture. And the second group should hold hands to form a human chain. The third group should have a chain by touching each other with only their fingertips. Now the fourth group of students should run around and try to break the three humans chain one by one into as many small groups as possible. Which group was the easiest to break and why? Because of last group easily to break, because touch with fingers also break your bone, right? And in first group very strong attached to each other, very strong bond with each other, so we can't break it, right? So next if we consider each student as a particle of matter, then in which group the particle held each other with the maximum force? Maximum force in first. Activity 1.7, take an iron nail, uh, a piece of chalk and a rubber band. Try breaking them by hammering, cutting and scratching. In such of the above three substances, do you think the particles are held together with greater force? Because of in a iron nail, in hammering mm, external force very high, and you know that chalk is very easily break down chalk bonds, and the rubber band not break down because of uh, this type of a flexibility with the solid and liquid mixing. uh, so this type of properties in mix, so their types of bound very strongly attached to each other. Activity 1.8, take some water in a container. Try cutting the surface of water with your fingers. And were you able to cut the surface of water? No. Uh, Very few times we will be able to cut down, but a long time this is not possible. What could be the reason behind the surface of water remaining together? Because of kinetic energy flow continuously. So we not break down for long time. And yes, we will be a long time, of course, easily can, but we will external force to keep like a machine and or a switch to off. The above three activity 1.6, 1.7 and 1.8 suggest that the particle of matter have force acting between them. This force keeps the particle together. The strength of this force of attraction varies from one kind of matter to another. And question, which of the following are matter? Air, chair, so you can choose it. And next, state of matter. Observe different types of matter around you. What are its different states? We can see that matter surrounding us uh, excite in the three different states: solid, liquid, and gas. These states of matter arise due to the variation in the characteristics of the particles of matter. Now let's study about the properties of these three states of matter in details. The force is remove sorry and now this is activity, so we can cover in next section.